Okay, welcome to day 2 of solving radical equations. We started this yesterday, so hopefully you got a chance to do that lesson already. But this one we're just going to keep going and do more solving and really focus on the idea of an extraneous solution. Okay, so I'll talk more about that throughout the video. But here's our first example, and just a reminder, basically we're going to cancel out these square roots by squaring both sides. Okay, so the start of this one is you square both sides. And then the tricky part is when you square this left-hand side, it's not just x squared minus 9. You have to write it with parentheses, and then you have to take x minus 3 times another x minus 3. Okay, so you're going to have to do the FOIL process there. Okay, and then the right-hand side cleans up the way we want, right? The root, the square root, and the 2 cancel out, leaves us with just 4x. Okay, so now we FOIL out. So we have x squared, a minus 3x, another minus 3x, and then a positive 9. Okay, and then kind of combine the like terms is our next step. Okay, and now we just have an x squared equation, a quadratic, and we can solve that with like factoring, graphing, quad formula, any of those things. The only trick is we need to get the 0 on one side first. So minus the 4x from both sides. We have x squared minus 10x plus 9. And then you can really pick. If you like the graph method here, that's probably what I would do. Certainly you could do your quad formula, right? Or this one actually factors. So it seems kids kind of forget this, but don't forget for 9, you have 1 and 9 as factors or whatever. So if you do minus 9 minus 1, that'll multiply to positive 9 and add to negative 10. Okay, and if you set those to 0 at this point, so do x minus 1 equals 0 and x minus 9 equals 0. That'll get you answers of 1 and 9. Okay, and then the thing I really want to hammer today is before these are guaranteed to be answers, I'm going to circle them. But you got to be a little bit careful because plug them in and sometimes it'll be what's called an extraneous solution. So I'm going to go back to the original equation here. Forget the little squares part. And I'm just going to put in 1 as our answer. So put a 1 here and a 1 here. So we'd have 1 minus 3 equaling square root of 4 times 1. So we end up with negative 2 equaling the square root of 4. And that ends up being false. If you treat this as the positive root, that is not a true statement. So since this is false, this is what's called an extraneous solution. So that's what they mean by extraneous. That is an extraneous where it seems like it's an answer, but when you plug it in, it doesn't work. Okay, so let's check our 9 just to be safe here. So if we put 9 in up here, 9 minus 3 equaling 4 times 9, and we get 6 equals the square root of 36, and that's a true statement. If we treat this as the positive root, we get 6 equals 6. So this one checks out, and that's a good answer. Right, versus the 1 would be considered, again, an extraneous solution. Okay, so all we're going to do in this lesson is a couple more examples like that with really highlighting this idea of checking, plugging them in and checking for extraneous. Okay, let's give this a shot. Pause the video, give it a try. All right, so on this one, we want to get the root alone first. So we're going to divide by negative 3 to get square root of 5x equaling negative 5. Okay, and now we're going to square both sides. Since we got that alone, just square both sides. And it wipes out the root here, which is what we want. It gives us 5x. And on this side, negative 5 times negative 5 is 25. Okay, and now everything's cleaned up nice and pretty. Now we just got to divide by 5, and we get an answer of 5. Only one answer this time, but we still want to check it for this idea of extraneous. So I'm going to plug it back in up here and see if it works out. So we're going to do negative 3 times the square root of 5 times 5. And we want to see, sometimes I put a question mark here, because we want to see if that comes out to be 15. So we end up with negative 3 times the square root of 25. Okay, and we end up with negative 3 times 5. Okay, and that does not equal positive 15. Negative 15 does not equal positive 15. Okay, so that means this is a bad answer. So this is extraneous solution. Okay, and overall means there really is no solutions. Yeah, all we got was one extraneous solution, so this one doesn't have any answers. Kind of a weird equation. Okay, next up is very similar to what we've been doing, except to wipe out a 1/2 exponent, you sort of do the reciprocal. Okay, so basically here, if you have 1/2, you just raise it to the 2/1 power. And the reason for that is if you do that, you multiply the numerators, multiply the denominators, and then you just get 1. Okay, so by raising it to that power, it wipes out the 1/2 on that side. Okay, so basically we got to square both sides, because if we square this side, we're also going to square that side. Okay, the alternate way to think of this is a 1/2 power is the same as a square root. So this question actually also could be thought of as 5x minus 1 with a square root over it equaling x minus 3. Okay, but however you want to think of it, you got to square it to get rid of the root part. Okay, so again, like to get rid of this 1/2, I raise it to the 2/1 power, but it's the same idea as you're basically just squaring is the key. All right, and the point is it'll wipe it out on that side, leaving you with just 5x minus 1. And then on the other side, again, we've got to FOIL this. So we've got to take x minus 3 times another x minus 3 and FOIL away. So we get x squared minus 3x, another minus 3x, and a plus 9. Combine our like terms in the middle there, so negative 6x. Okay, and then to start solving or finish solving it from here, we just got to get 0 on the one side. So we're going to minus 5x and add 1 to both sides. Sorry, that's a bad looking 1 there. So we get 0, and then we have x squared minus 11x plus 10. Okay, and again, we want to try to factor and solve that. Though you could graph it on your graphing calculator if you want, or do the quad formula. But this one does factor pretty easily. It's just two negatives again, x minus and x minus. Right, it's got to multiply to positive and add to negative. So we need two negatives. And I think it's just 1 and 10. That'll give us negative 11 in the middle. If we set it to 0, then we get answers of 1 and answers of 10. Okay, but the final step here is we got to check for extraneous. Okay, so I kind of ran out of space, but I'll bring it down and show you what I mean. All right, so here is our original setup. So we need to check these answers one at a time. So I'll do the 1 first. So we'll try 5 times 1 minus 1 to the 1/2 power. Remember, 1/2 is the same thing as a square root. And then over here we'll have 1 minus 3. So we end up with, let's see, this would be 5 minus 1 to the 1/2 power. And this side is negative 2. So we end up with 4 to the 1/2 power. And we want to see, does that equal negative 2? And again, if we treat it as the positive root, the answer is no. 2 does not equal negative 2. So this one is no good. That's an extraneous solution. Okay, and then if we check 10, I'm going to guess 10 works out here, but let's put it in up here. So we have 5 times 10 minus 1 to the 1/2 power. We want to see if that'll equal 10 minus 3. And we will get, this would be 50 minus 1. So we'll have 49 to the 1/2. And then we'll have 7 on that side and 49 to the 1/2. So that again is like a square root of 49, and that is 7. So we get 7 equals 7. So this one's a good answer. So we have just one answer here of 10. And 1 would be an example of an extraneous solution. Okay, one final solve one. Again, I'd pause the video and see if you can do this whole thing now. Put it together with the check for extraneous. So pause the video, give it a shot. Okay, what happens here is we can square right away to get rid of this square root. So the left-hand side is now x squared. The root is gone from the other side, so that's a good thing. Okay, and now it's a quadratic, so we're going to do quadratic formula, factor, graph, any of those things, but we want to get 0 on one side first. So we want to minus the 8x and minus 15. So we get x squared minus 8x minus 15 equals 0 on that side. Okay, and then we want to try to solve this. All right, so I'm a little worried this isn't going to factor. I think I might have messed up this question, to be honest, looking at it. So in my head, I want to try to factor this, and I think it should be like 5 and 3. In my head, I think that. But it'd have to be minus minus, and that wouldn't make plus, wouldn't make a 15 here. So since I messed that up, I'm just going to go here and go to land and make believe and pretend that this is a minus. Sorry. And then that would make this a plus here and a plus, so it would make it a plus 15. Then it would work out to be minus 5, minus 3. I'm guessing that's what I was thinking. And then anyways, we'd have answers of 5 and answers of 3. And then we just have to plug it in and check for extraneous. So our check would look like, check them one at a time. So we'll check x5 first. We would have, does 5, maybe I'll try to write it nice, does 5 equal 8 times 5 minus 15? Now that I got the minus in there, so we'd have, does 5 equal 40 minus 15? And it looks like it's working out because 5 does equal the square root of 25, so that checks out. So this is a good answer. And then if we check x3, my guess is it's not going to work, but we're going to do 3 equals 8 times 3 minus 15. So we end up with 3. Does that equal 24 minus 15? No, I think it's going to work out actually, because 3 does equal square root of 9, so that one checks out. So this one looks like it has 2 good answers. I stand corrected. So kind of interesting. That one actually had 2 good answers because they both gave true statements. If we think of these as positive roots, they both gave true statements when they put them in there. Okay, that's all I got. Thank you for watching.